So in chapter 9.3, we're going to be going over polynomial functions, operations, and composition of functions. So starting with the definition of a polynomial function, so hopefully we remember what a polynomial expression is. It's essentially the same thing, except it's a function now. So a polynomial function of degree n is going to be defined as f of x, so we're using function notation. F of x is this whole nasty looking expression. So all of the a values, a sub n minus 1, a sub 2, a sub 1, a sub 0, those are just numbers. And the n's, so like the exponent, x to the n minus 1, those are whole numbers. So they're just positive whole numbers for the exponents on the variables. And a polynomial is typically written in descending order in terms of the exponents. So we're going to be doing the same operations that we've already done. We're just going to be using a little bit different notation here. So we're going to be adding, subtracting, multiplying, and dividing. So if f of x and g of x are two polynomial functions here, we're going to be using these notations. So originally we could have just said f of x plus g of x, added them together, combined like terms. We're going to be doing that, except now we're going to be using this notation on the left. So f plus g of x is the same thing as f of x plus g of x. So we're just going to be adding the functions and combining like terms. Same thing with subtracting. We're just going to write it as f minus g of x. Same thing with multiplying. It's f of x times g of x. We're going to write it as fg, so f times g of x. And dividing, instead of f of x divided by g of x, we're going to write f divided by g of x. Okay, so let's do some examples here. So we have f of x is 2x minus 1, and g of x is x squared plus x minus 2, and we want to find f plus g of x. So all this means is f of x plus g of x. So all we have to do is add these together. So it's going to be 2x minus 1 plus x squared plus x minus 2. So combining like terms here, we don't have to worry about distributing anything. We can essentially drop those parentheses. We're going to be left with x squared plus 3x minus 3. Okay, so we just got that from combining like terms. So that means f plus g of x equals all of that. Next one, f minus g of x. So all this means is f of x minus g of x. So plugging in these functions here, we're going to get 2x minus 1 minus x squared plus x minus 2. So this time we do have to be a little bit careful because we have to distribute that negative into g of x. So it's going to be 2x minus 1 minus x squared minus x plus 2. Combining like terms, that's negative x squared plus x plus 1. So that's our answer for f minus g of x. So keep in mind for how I'm reading this off, it's not f minus g times x, it's f minus g of x. Okay, next one we have f times g of x. So what this means is f of x times g of x. So all we have to do is plug in the functions and multiply them together. So 2x minus 1 times x squared plus x minus 2. So now we have to distribute each term from the first function into each term from the second function. So multiplying the 2x through first, we're going to get 2x cubed plus 2x squared minus 4x. Now distributing the negative 1, that's negative x squared minus x plus 2. And now combining like terms, we're going to get 2x cubed plus x squared minus 5x plus 2. And that is our answer for f times g of x. And for the last one here, we have f over g of x, f divided by g of x. So this just equals f of x divided by g of x. So all we have to do is divide them. So it's going to be 2x minus 1 over x squared plus x minus 2. And normally you might try to factor them and simplify it, but that's actually all we can do. So that would be our answer for this one. Okay, so that's essentially all review except for the new notation. So now for something new is composite functions. So this is going to be another way to combine two functions. What we're going to be doing is essentially taking one function and plugging it into the other function. So one function is going to be the input to another function. Okay, so the notation we're going to be using is going to be the composite, or the composition of f of g is going to be written like this. So we have that little circle, but it's an open circle. That is not multiplication. It means we are doing f of g of x. So in this case, it would be everywhere there is an x in f of x, you're going to plug in g of x. You're going to plug in a function into all of the x's in the other function. So let's do a couple examples here. So let's say we're given f of x is x squared and g of x is x plus 3. In the first one, we want to find f of g of x. So it may help to write it down the way I had it written down up there. That's the same thing as f of g of x, written like that. That might help you determine what to do. So all of the x's in f of x, we're going to plug in g of x. So instead of x squared, it's going to be g of x squared. So now we can actually plug in g of x. It's x plus 3 squared. So we can take this and expand it out. We would FOIL it and get x squared plus 6x plus 9. Okay, so that's the composite function f of g of x. So let's do g of f of x. So this is going to be the same as g, and then plugging in f of x everywhere there was originally an x. So g of x was originally x plus 3. So instead of x plus 3, it's going to be f of x plus 3, which means we're plugging in f of x into every x in g. So f of x was x squared, so this is going to become x squared plus 3, and that's actually as far as we can simplify it, so that's going to be the answer. Okay, so now for the next one, we have f of g of negative 1. So this means we want f of g of negative 1. So we actually have f of g of x already, so we can use that function and plug in negative 1. So from the first part for this question, we found that that function was x squared plus 6x plus 9. So all we have to do is plug in a negative 1 into there. So it's going to be negative 1 squared plus 6 times negative 1 plus 9. We simplify this, it's going to be 1 minus 6 plus 9. And that gives us a value of positive 4. So f of g of negative 1 equals 4. So another way that you can do these ones that's a little bit longer is we could have evaluated, if we think about it in terms of this one up here, we could have evaluated g of x when x equals negative 1. That would give us an answer, and then plug that answer into f of x, and that would give us f of g of negative 1. Okay, and then another one, g of f of 2. So we want g of f of 2. So once again, I'm just writing it this way in case that helps you realize what to do. We already have g of f of x, so all we have to do is plug in that value into that function. So g of f of x we found was x squared plus 3. So all we have to do is plug in a 2, So that's going to be 2 squared plus 3, which is 4 plus 3, which is 7. So g of f of 2 equals 7. Okay, we'll do one more example here. So we have f of x is 3x minus 4, g of x is x squared minus 2x plus 6, and we want to find f of g of x. So once again, we can rewrite this as f of g of x. So everywhere in f of x, there's an x. We're going to plug in g of x. So instead of 3x minus 4, it's going to be 3 times g of x minus 4. And now we can actually plug in g of x. We can plug in x squared minus 2x plus 6 in parentheses. And now we just have to simplify. So distribute the 3, we get 3x squared minus 6x plus 18 minus 4. Combine like terms, 18 minus 4, we get positive 14. And that's our answer for f of g of x. And now for g of f of x. So g of f of x is going to be the function g with f of x plugged into all of the x's. So g of x was originally x squared minus 2x plus 6. So instead of an x, it's going to be f of x. So it'll be f of x squared minus 2 times f of x plus 6. And now we have to plug in for f of x here. F of x was 3x minus 4. So that's 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So 3x minus 4, you would have to distribute that out. So I'll do it over here on the side. 3x minus 4 squared equals 3x minus 4 times 3x minus 4. We would end up getting 9x squared minus 24x plus 16. So that's going to be that first big term expanded out. And for the next term, we have to distribute the 2. So minus 6x plus 8 plus 6. And then we just have to combine like terms here. We get 9x squared minus 30x plus 30. And that is our g of f of x. And for these last questions here, we want g of f of 1. So we just actually found g of f of x, so I'm going to rewrite that. So all we have to do is plug that in. So it's going to be the same thing as if we wanted to do g of f of 1. So plugging that in that function, it's 9 times 1 squared minus 30 times 1 plus 30. So the 30s are going to actually cancel out, and we're going to be left with 9. So g of f of 1 equals 9. Okay, so once again, we could have evaluated f of 1 first. We could have gotten a value and plugged that value into g of x, and that would have given us out 9 as well. Okay, so that is it for this section.